Guys, welcome back to TechDose, and in this video we will look at find the lexicographically largest string from the box 1 problem, which is from Leetcode number 3403. We will be looking at the optimal solution using 2-pointer. So this video may be long, but we will be looking at all the steps along with reasoning. So stay tuned till the end. In this problem you are given a string word and an integer num friends. Alice is organizing a game for her num friends. There are multiple rounds in the game where in each round, word is split into num friends non-empty string such that no previous round has had the exact same split. All the split words are put into a box. Find the lexicographically largest string from the box after all the rounds are finished. So given an example, let's say DBCA, and it is saying about having two number of friends. Two number of friends means we have to do two slicing. That means if you divide it, then it will become two slices. If you divide at the first point, it will create D comma BCA. Then if you divide at the second point and not at the first point, it will create DB and CA. And if you divide at the third point and leaving out all the other points, it will create DBC and A. Now you cannot divide right in the beginning or at the end, because the problem statement is mentioning that each one of the friends should get a non-empty string, right? So you cannot have two consecutive slices in between two characters. You cannot put two slices, or you cannot put slice in the beginning. Now out of all these combinations of strings that you have got, you have to just return the one which is lexicographically the largest. So if you compare all these strings, DBC is the one which is lexicographically largest, and that is why this is the answer, right? So in order to solve it with a simple approach, you can try to generate all possible slicing in order of n square time, and from there you can select the one which is lexicographically largest and print it. So in this case it will be DBC. Now if you follow this approach, is it going to work? If you take n square time for creating all possible slices, then you look that in this case, since the total length of the word is only 5 times of 10 to the power of 3, then if you take n square, it will become 2.5 times of 10 to the power of 7, right? Because 10 to the power 3 square is 10 to the power 6. So this is within the limit of 10 to the power 8, so it can pass, right? But this is not the optimal solution. If you take more than n square time, then definitely it is not going to pass. In this particular case, we will be looking at an optimal approach using a linear time algorithm. Now in this case, the word consists only of the lowercase English letters, and the num friends will always be within the limit of your word length, so that it will always be possible to create valid slicing. That means each of the friend can at least get a single character. Minimum a friend can get is a single character, right? Now let's look at some of the observation. The first point is about substring slicing. Let's say that we are given a string of 7 size and our number of friends are 3. Now the smallest slice that you can give to a friend is only size 1, and this has to be the smallest. Size 0 is not possible because each friend should get non-empty size substring, okay? And the largest slice that you can give to a friend will be when you give the rest of the friends one size substring, right? So you have total of 3 friends. So if you give one friend the maximum size, then the rest of them should get one size. So you know that if you remove 1 from 3, it becomes 2. So 2 of them should get one size. That means 2 size will be accommodated. And so the one guy which is left at the end will get n minus 2, where n is the size of the entire string. So the string size is 7. Okay, so 7 minus 2 will be 5. So in this case, you can say that if you have 3 friends, then the maximum that you can assign is size 5. So in general, if you have total string size to be n and the total number of friends to be f, then the largest substring size that you can give is n minus f plus 1. Okay, in this case it was 7 minus 3 plus 1, which was equals to 5. That is how we had got the value 5 here, isn't it? So this is about the substring slicing. So the range of the slice size for any friend will be from 1 to n minus f plus 1. Okay. Now let's understand about lexicographical ranking. So in this case, if you take two string s1, s2 and try to compare then we will be comparing always from the highest weighted character to the lowest weighted character position, right? So in lexicographical ordering, the highest weight is always on the leftmost side and the lowest weight is always on the rightmost side. Just like you have in the decimal number system, if I write 253, you know that this is the hundreds location, this is the tenths location, and this is the ones location, right? So whenever you say is 153 larger or 253 larger, then you don't compare from the right side, but it is faster and easier to compare from the left side. It should be correct, isn't it? That if 2 is greater than 1, then I don't care about the other characters. This 253 has to be greater than 153. So if you just go from left to right, you compare this A is matching with A, B is matching with B, but this A and C are not matching. This is the first point of mismatch. At the first point of mismatch, if you find that this C is larger than A, then S2 will always be larger than S1. Even if it did not have this character, still S2 will be larger than S1. Okay. Now if you look at the second example, in this case, you keep matching the corresponding characters, they kept matching. But one of the string ends at the third location. So in this case, you will say that if all the characters were matching and one of the string actually ends before the other, then this S1 is going to be larger. So the length will only matter when all the corresponding position characters were matching. If there is a mismatch, like if this was C, where C is greater than B, corresponding matching, then this AC, that means string 2, will be greater than string 1, right? So the high priority thing is to match the corresponding characters, and if all the corresponding characters matches, then the length comes into picture. We saw this because this will give us the idea to understand how to generate the lexicographically largest string. Therefore, in this case, if we want to get the lexicographically largest string, we should follow two rules. Rule number 1 is the most important, and rule number 1 says that we need to maximize the first point of mismatch. That means try to take the high ASCII value characters on the leftmost side. So if we are given the character set ABC, where I can use each character exactly once, and I am asked to form the lexicographically largest string, then definitely I will be trying to put the highest ASCII value on the left side, second highest next to that, and the third highest next to that, isn't it? This will give me the largest lexicographical string. But can you say that I will not be using one of them and I will just be using CB? No. Because if you can use all of them, then definitely we will take the larger length string instead of a smaller length string, right? So the first point is maximize the value, the entire string value, by keeping the high ASCII character to the highest weighted position. That means the highest one will go to the highest weighted position, second highest will go to the second highest weighted position, and so on. Build the string, and you should also keep in mind that we will have to maximize the length, because if we have a certain characters in hand, use them all. Okay, use them all, because if you even leave a single character, then we can prove that if you had used it, you can get a higher lexicographical ranked string. Okay. So I hope these two rules are clear. Once it is clear, let's try to understand the goal of our problem. In our problem, I will be just explaining by a bunch of examples. So in the first example, we have AB, A double B, and let's say the number of friends are 2. So what should be the result? Where should I put the slicing? I have slice positions between 0, 1. I can only put one slice because we have just 2 friends. If I put one slice, left side will go to one friend, the right side will go to another friend. So the first option is in between 0, 1, second option, third option, and fourth option. The number of options will depend on the size of the string, size of string minus 1. Okay. So at what position should you put the slice so that you get the lexicographically largest string? I have to just maximize at least one of the string. Okay. If you put here on the left side, you have A, on the right hand side, you have B, A, double B, right? If you try all the options, here you have A, B, A, double B. Here you have A, B, A, you have double B. And here if you put, you have A, B, and you have a B. If you try all the options out, you will get at this point where you get double B, right? Double B is the largest lexicographical string that you can get out of this string. And that is how the result has come as double B. Now if you compare the next string, it is a double b a b. Now I need to put only one slice because I have two friends. So if I put a slice optimally, it is going to be between 0 1, where I will get double b a b. Okay. Now how I'm deciding that result is going to be this. The result size will always be in the range of 1 to n minus f plus 1, where 1 is the smallest size and n minus f plus 1 is the largest size assignment to the result. Okay, so in this case, n size is 5 minus 2 plus 1, it is going to be 4. So this is 2 within the range of 1 to 4, so it is fine. Similarly, here also it will be in the range of 1 to 4. So this is 4 length, so it is fine. If you look at the third string, then again my number of friends are 2, so I just need to put one slice. Fine. So if you put a slice here, I know that it is not a correct slice, but if you put a slice here, then you will get the lexicographically largest string. Lexicographically largest string. So first I will get the lexicographically largest string, double b a b a. Then I will check the range. The range is from 1 to 4 in this case as well, due to the same explanation. Okay. But the size here is 5. So if the size is 5, and I know that this is the lexicographically largest string that I can get, then from which side will I start removing the character? If you start removing the character from the beginning, then you will get b a b a. And if you start removing from the end and not from the beginning, then you will get b b a b. So which one is going to be larger? Definitely b b a b is going to be larger 4 length string as compared to b a b a, right? And that is why I will always slice from the end, not from the beginning. So if you get a larger string, then you have to slice up the unwanted characters only from the end, because it is always going to be a larger string if you keep the initial n minus f plus 1 characters. So I will be slicing only from the end point, and we will be getting BBAB, and the rest part is going to the second friend. So if you think about how I am deciding on what should be the substring that I should consider, in all these three examples you will note that whenever we try to pick a substring choice, it was always the largest suffix. Okay, it was always the largest suffix that I was picking. In the second example as well, we were picking the largest suffix. This was the largest suffix. I am talking about the lexicographically largest suffix. In the third example as well, the lexicographically largest suffix was the entire string itself. Okay, so it was oversized and we did trimming from the right hand side. From the least significant position we were trying to trim. If you look at example number 4 here, then in this case, if I take n value equals to 8, that means we have 8 characters, our number of friends are 3. Then the allowed size will be from 1 to n minus f plus 1, where 8 minus 3 is 5 plus 1 is 6. So the largest suffix size should be ranging in the range of 1 to 6. If you find the largest suffix size, it will be going from 4 to 7. This is the largest suffix string, isn't it? So if you get it, is it fitting in the range of size 1 to 6? Yes. So this will be the final result as well, right? If you just take another example, this is example number 5. Then in this case, I am again taking 8 number of characters, number of friends are 3. So the allowed range of size is from 1 to 6. Now what is the largest suffix? How do you get it? Largest suffix will be when you put a slice here. Okay. So what is the length of the string? You get from 1 to 7. So this is a length 7 string. 0, 1, 2, 3, 4, 5, 6. So length 7 string. But what is the allowed limit? It is from 1 to 6. And this is a 7 length string. So where should I slice? I will slice from the right hand side, least significant weighted position. And that is how I get ZZA, ZBA. Right? So in order to get the largest lexicographical string, our goal should be to take the given string and find out the largest suffix. From the input string, find out the largest suffix. Then check if the suffix size is falling in the range of size 1 to n minus f plus 1. If it is falling, don't do anything. This is the final answer. If it is going outside of this range, then slice from the end, or you can say that take from index 0 to whatever is the max size, n minus f plus 1, something like that, right? Okay, so I hope our goal is clear what we are trying to do. So now we will be focusing on calculating how to get largest suffix optimally from the input string, and for that reason we will be doing the optimal two pointer matcher. So in first glance it may not be even obvious that two pointer will work, but let's flow through the process, and by the end you will get all the exact reasoning of how two pointer works in this scenario. So in this case I am taking an example S with all the special characters. The reason for me to take special character is you don't know what is the ASCII value and I don't want you to know. So if I put X, Y and all those characters, then that will seem like a valid input and you may get confused, and that is why I am taking all the special characters from 0 to 7. Now using the two pointer, let's see how to get the largest suffix, right? So one of the case that can occur, like there can be 2 or 3 cases that can happen when applying two pointer for finding the largest string. So let's say that we are putting I pointer at 0th location and J pointer at first location. We will try to match the suffix starting at ith location and the suffix starting with the jth location. Whichever suffix is larger, that I will try to retain. So I will try to find out the suffix starting at ith location where this is the largest suffix. So by the end of this parse, one time parse of the string, I will be pointing to a position, that means the index in the given string, from where if I take the slice till the end, it will be the largest suffix. It will be the largest suffix. So that is my goal. But I will assume that I, the index I, will be pointing to 0, indicating that right in the beginning I am assuming the largest suffix starts at index 0. Now J will be trying out all the positions on the right hand side, and we will try to compare that if I had started the suffix not from I but from J, then will I get a larger suffix or will I be the optimal? If at certain point I get to know that suffix starting at J will be larger, then I will update I to J. I will reassume the new start position and I will again check on the right hand side. Okay, this is the overall idea. Let's see how it works. So I have already created a scenario. If you look at this scenario, it says string at 0 is equals to 1, 1 is equals to 2, 2 is equals to 3, but 3 is greater than 4. That means at is equals to star, star equals to hash, hash equals to dot, but dot is greater than ampersand. Okay, so I have created the exact example as well, B, 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 A, and the rest of the 3 characters I'm just keeping them as special because I don't want to care about them. So in this case, looking at this first 3 assignment, you know that 0, 1, 2, 3 are same, so I have assigned them B. And the last one, S at 3 being greater than S at 4, so I have assigned S at 4 a lower value, which is A. So if this is the case, then how will the matching go? If I start a substring at 0 versus if I start a substring at 1, what will be coming? If you start a substring at 0, then the values will be B, 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 A, and then you have gamma, alpha, delta, and so on. And if you start a substring at 1, then it is going to be B, 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 A, and then you have gamma, alpha, delta, right? So if you look at these two suffixes, suffix starting at 0 and the suffix starting at 1, which one is larger? If you see the first point of mismatch, you will find that suffix starting at 0 is larger. Suffix starting at 1 is not larger, right? You can just see here. And that is the property that we will try to use. Okay, so let's try to see how to do this matching using two pointer. So what I will do is match this I with J, and I will try to create a jump, which is the gap variable. Try to match this ith with the jth item. If they are equal, then gap will increase by 1, and I will always be comparing S at I plus gap compare with S at J plus gap. So now we are trying to compare S at 0 plus 1, which is this B, with this B, J plus gap. Okay, they are again matching, so we move a gap size to 2, and we will match this second character with the third character. Again they are matching, increase the gap size, and now I will match this third character with the fourth character. This is the first point of mismatch, And if you see this mismatch, what is the case? The case is asset I plus gap is greater than asset j plus gap. This is the thing that is happening here, right? If this is the thing that is happening and our goal is to get the largest suffix string, then where should be the next j start point to get the largest suffix? Will it be 2, 3, 4, 5 and so on? What will be the next j position? Because I know that this b and a are not matching, so what to do? So whatever I had assumed initially, that the suffix starting at index I, that means at 0, is larger, is true. For the time being it is true. So let's say that in the next iteration you will move j to j plus 1 and again start comparing. Then it does not make sense. It does not make sense because you know, these characters here b b b and these characters here triple b had all matched, and that is why you were matching this third character with this fourth character, right? The previous three characters has matched. So it does not make sense in the next time to restart the entire process with j plus 1. This does not make sense, because if you do that, then the next time you get suffix starting at s2 will be, this will be left shifted by one time. You get b b a gamma alpha and delta. So in this case the first point of mismatch will come even on the left side, and this mismatch is not going to go until you get rid of this a. Until you get rid of this a, it is not going to go, right? So where should be the next start position? The next start position should come right on the next index of where the mismatch you had seen while moving the j to the right hand side. Because if you don't get rid of this a, if you continues to be at any position, then the suffix starting at I, that means at 0, is always going to be greater. Therefore, the j must go to j plus gap plus 1. That means 1 plus 3 plus 1, which is going to be 5. Okay, so that is how we will be calculating that j's optimal next position is going to be j plus gap plus 1. Okay, so this is how I have calculated index 5. So I think this entire case is clear, that if at any point you are comparing the suffix starting with I versus the suffix starting with j and moving each of them forward by matching character by character, and if you find a first point of mismatch where it says that asset I plus gap is actually greater than asset j plus gap, then you will be updating j to the next position of the mismatch, which is going to be j plus gap plus 1 to go to the next character, right? Because j plus gap was the first point of mismatch. So I think case 1 is clear. Similarly, if you assume another case where they are equal, the equality case I am not considering, because if the I plus gap and j plus gap are equal, then you know that we will be moving the gap value forward. This case was already covered inside case 1. So the next case is going to be when asset I plus gap is less than asset j plus gap, isn't it? So let's see what happens there. So in this case again I am putting the same special character example, and I will try to again start our calculation by assuming that substring starting at the ith character, that means a 0th location, will give me the largest suffix, and I will try to check with all the starting suffixes at the jth location. Again I will be assuming asset 0, 1, 2, 3 to be all equal, and this is the case that I have come up with. But in this case I am assuming that asset 3 is less than asset 4. So dot is less than the ampersand. So I have taken first 4 as A's and the next one as B. Okay, just to create that scenario. Now in this case again I will be taking the gap value to be 0, and as long as this ith and I plus gap and j plus gap are matching, I will be incrementing the gap value, and you can match A with A, again it is matching, increment the gap value, match this A with A, again it is matching, increment the gap value, match this 3 with 4. So this A is not matching with this B, and in the previous case we had seen asset I plus gap was greater than asset j plus gap, but in this case we have asset I plus gap less than asset j plus gap. Then what to do? Then this is quite simple. You know that if the substring starting with I, at some point you found that okay, this is less than the substring starting with j, immediately you will change your assumption from previous I to the new jth location, because the new start point, that means the jth substring is larger, that means I will get a larger suffix if I start with the jth location and not with the previously assumed ith location, isn't it? So that is how I will be assigning I to j. Okay, but where should the j go? If you think about j, where should j go? J will go to j plus 1 or somewhere else. Well, if you look at the matchings, what matchings we had done, 0 was matching with 1, 1 was matching with 2, 2 was matching with 3, and 3 was not matching with 4, right? So if you look at the suffix starting at 1, it will be triple A, B, gamma, alpha, delta, where gamma, alpha, delta are not known. Suffix starting at 2 is given, suffix starting at 3 and suffix starting at 4 are given. So suffix at 1 is strictly greater than suffix as 0, because we found the mismatch between this third and the fourth index, and that is how the I was assumed to I equals to j. This is what we did. But when it comes to updating the j index, we have multiple options. One of the option is to go to move j to j plus 1. In the last case, we had moved j to j plus gap plus 1, and I hope it was clear. This was just to make this mismatch point go out of bound. That means once you do left shifting, then this a should be lost, and that is why if you do left shifting gap plus 1 number of time, then only it will be lost. That is why we were going to that location. But in this case, you know that b is larger, isn't it? So where should I go? J will be updated to the new index b. This is quite obvious, because I know that even if suffix at 1 was greater than suffix at 0, okay, the I was actually updated. But if I pick any other suffix start point, let's say suffix at 2, you may argue that suffix at 2 is greater than suffix at 1, so it is a better option. Why didn't I start at 2? And you will also say that suffix at 3 is a higher ranked number, because this mismatch is b greater than a, so it puts suffix at 3 greater than suffix at 2. That means suffix starting at third index is greater than suffix starting at the second index. So you will say that, okay, why not we consider this third index? But you should also note that at the first point of mismatch, this was a higher character. So it does not matter whether if suffix 2 is greater or suffix 3 is greater, it will always be outranked by the suffix starting at 4, where the mismatch had actually happened. You can make your own examples and you will see this happening. Okay. And that is why j must be updated to this index where the mismatch had happened. What is this index? This index is actually the previous I value plus gap plus 1. The previous I value, not the new I value, because if I update I with j, the I index is changing, right? So the previous I value plus gap plus 1. This is the index that I care about. Okay, this is the index that I care about. Or otherwise, there can be another scenario where I is too far away from j, where some characters had matched, okay, but there is still some characters in between which were not matched. So in that case, j will become j plus 1, okay. So I leave this up to you to check. You can just enumerate and make a larger example to think about this case. But I hope this case is clear, where the j will be assigned to I plus gap plus 1. So we will always be moving j to the right hand side, and we will try to take the maximum of j plus 1 comma I plus gap plus 1, because if I take the maximum, then it will eliminate this case as well, because if there are a lot of gap, that means a lot of items in between j and I, at least one item which was not processed, then I plus gap plus 1 will come on the left hand side of the previous j value, which should not happen. If you are trying from j location, that means you have tried all the left hand side location, isn't it? So in the next iteration, your j must always keep moving forward. The next j should always be at a larger index than the previous j. It should not move in the backward direction. And that is why we will take maximum of j plus 1 comma I plus gap plus 1. So I think this second case is also clear, right? Once you have understood about both the cases, then we can see the processing of getting the largest suffix using the 2-pointer technique. Right, the goal here is to find the largest suffix where I at the end will be the start point of that largest suffix. So initially, if you take example number 1, then I have taken a simple example AA with 2 friends. That means I can only make one slicing, and you know the range of maximum slice size is going to be from 1 to n minus f plus 1, which is 3. That means 1 to 3. Minimum is 1, maximum size is 3. So what I have to do? I know there are 3 cases. 2 cases I had shown. One case was equality case. If ith and jth characters are matching, that means simply I can say that I plus gap character is matching with j plus gap character, then I will simply increment the gap. The second case was about I plus gap character was less than the j plus gap character. I have already told you these things. And if I plus gap character is greater than the j plus gap character, then you know what to do, right? Whenever you reset the values, you will also reset the gap, because now a new comparison is going to start. So the gap will always restart with 0 whenever the reset is happening. Okay. This is the only case where reset is not happening. We are continuously moving forward. So let me show you 3 examples, after which you will absolutely be clear what we are trying to do. So in this case, when we take double A double N, then we match the 0th character with the first character. They are matching, so the gap value will increase by 1. Then match I plus gap, that means first character, with j plus gap, second character. So they are not matching. If they are not matching, which case is hitting? This asset I plus gap less than asset j plus gap is hitting. So in this case, I will be saving the previous index of I, and then I will be updating, let's name it save. I will be updating I to the new j value. Okay, and where will the j be going? J will be going to max of j plus 1 comma previous I value plus gap plus 1. That means j will be going here anyway. Both the values are going to be 2. And now gap will be reset to 0, and again continue the process. So again you compare this I plus gap with j plus gap. Okay, so they are not matching. So what to do? Again asset I plus gap is less than asset j plus gap. So what to do? Again, if you repeat the process, I will come here. This will be the save value. The gap size is 0. Where will j go? J will go to save plus gap plus 1 comma j plus 1. So this is one scenario where j plus 1 is larger than save plus gap plus 1, right? Save is 1, gap is 0, plus 1 is going to be 2, j plus 1, that is 2 plus 1 is going to be 3. We take the max, so j is moving forward. This was the other case that I was talking about here, right? Okay. So j is moving forward. Now you compare this, again reset the gap to 0. It is already 0. Compare this 2 with 3. They are matching. So make the gap 1 and compare this 3 with 4, which is out of bound. So you are done. When j plus gap is out of bound, you are done. When you are done, what is the start position? It is pointing to index 2. So what is the substring slice that you will get? That means the suffix slice from 2 till the end, it is nn. Okay. So when you get nn, you check the size of it. This size is 2. And the allowed size is from 1 to 3. So this is fitting within the size. So nn is your answer. This is the lexicographically largest string that you can make by slicing. Okay. If you take example number 2, now I will be doing it a little bit faster. So in this case, I will be assuming this to be I and this to be the j1. So what is the size that is allowed? It is allowed from 1 to, you can say, n minus f plus 1. So 1 to 6. Where the number of friends are 3. The n value is 8. There are 8 characters. So now you compare 0 with 1. Are they matching? They are not matching, right? I have made it separately. So 0 is not matching with 1. So in this case, what to do? Asset I plus gap is less than asset j plus gap. So this I will be saved using a save variable. I will be made equals to j. J will be equals to max of save plus gap plus 1, which is 1. So max of 1 comma j plus 1, that is 2. So j will be going to this 2. Okay, and now again compare. Now b is greater than a. So this third case is hitting, right? I plus gap is greater than j plus gap. So j will be reset to j plus 1. That means you can say j plus gap plus 1. And the gap will be reset to 0. Again compare b with b. They are matching. So gap will become 1. Compare this 2 with 4. They are not matching, and a is less than z. So what to do? Again save this index in save variable. I will be made equals to the new starting point, which is index number 3, and j will be made equals to save plus gap plus 1 or j plus 1. So simply j will come here. Okay, you can try it out yourself. You will understand it even better. So now you can compare this 3 with 4, the gap value being 0. 3 with 4, they are not matching, and b is smaller. So what to do? Again this will be saved and you will make I equals to j, then j will be equals to max of j plus 1 comma save plus 0 plus 1. So it is going to be this index 5. Now you compare z with z, it is matching, so move the gap value to 1. So compare this 5 with 6, 5 with 6, so 5 is larger, so reset j to j plus gap plus 1, that means the next character. Okay, and now you compare this 4, that means this z with z, they are matching, so move this to 5 and move this forward, and then you are done. When the j is out of bound, you are done. So where is the I slicer? It is at index 4. That means if you take the slice from index 4, you should get the largest lexicographically ranked string. Now check the size. The size of it is 4, which is falling in the range of 1 to 6. So this is your answer, ZZAZ, right? Now let's take the third example. In the third example, you have n value 8, number of friends are 4. So n minus f plus 1 is going to be 5. Okay, so I am allowed to have the largest string in the range of 1 to 5 range. Now let's see. Again, I will be taking I and j values and try to process it. So check this, a is less than b. So what I have to do? I have to save it in the save variable, make I equals to j. J will be equals to this value, max of j plus 1 comma save plus gap plus 1. Okay, fine. So currently this I value is at 1 and the j value is at 2. Now if you want to again process b, compare with z. Again b is smaller, so what I have to do? Again save it, increment, assign I to j. J will be equals to max of j plus 1 comma save plus gap plus 1. Okay, so I will remain here and you see j will be at 3. Now this second and third characters are matching, so gap will become 1. So move both of them forward. Z and a are not matching, but z is greater than a. That means you reset this j value to j plus gap plus 1. Move immediately to the next character, right? The left shifting logic which I had explained you, and reset the gap to 0. J is again restarting at 5. Now compare this 2 with 5. They are matching. Compare this 3 with 6. They are not matching and z is larger. So what to do? The gap value was 1, right? So move j to j plus gap plus 1 and reset the gap value to 0. Again match this z with a. They are not matching. So move the j to j plus gap plus 1 and j is out of bound. You are done. So I will be remaining at index 2. So what is the slice that you get? Z, Z, A, Z, B, A. And what is the size? 0, 1, 2, 3, 4, 5. So the size is going to be 6. And what is the allowed size? It is in the range of 1 to 5. So I need to slice out 6 minus 5 characters from the end. You know, it is going to be the optimal one, right? So take this slice by using the substring function, and this will be your final result, ZZAZB. This will be the lexicographically largest string. Okay, so I think it is clear. This entire process involves exactly one time parsing of the entire string, so the time complexity is going to be order of n, and ignoring the substring slicing, I can say that the space complexity is going to be order of 1. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the words and the num friends. So I'll be finding the word size, and if the number of friends are 1, then the given string will be the answer. We cannot make any slicing, right? So we need to return the word. Otherwise, if I have more than 1 friends, then I will be starting the processing. You know, I will be 0. That means initial start of the largest substring will be assumed to be index 0. J is the one which will be comparing all the possible start position with the ith one. If we get a better option, then I will be assigned with J. Otherwise, J will continue to try out all possible starting positions. The gap is for matching 2 possible starting position at I and J, and if they are continuously matching, then the gap will be only saying about what all delta position should we match. Now let's find out the largest suffix. So this code I had already shown you while showing you the examples, right? So until the j plus gap is out of bound, we have three cases, right? The first case is when I plus gap is same as j plus gap, so we do gap plus plus. The second case is when I plus gap is less than j plus gap, then the save value will be saving the ith index. I will be assigned j will be max of j plus 1 comma save plus gap plus 1, and gap will be reset to 0. The third case was when I plus gap will be greater than j plus gap. In that case, j will be j plus gap plus 1 and gap will be again set to 0. So this all I have already explained you in the dry run. And at the end, we need to return using the substring function the substring starting at the ith index and should be of the size n minus f number of friends plus 1. If let's say that you got a string double z and your n minus f plus 1 value is 4, then even if you take a substring starting at this index I which is 0 and you say that I will take 4 characters, it will always by default take the 2 characters in C++, right? So this was the entire solution. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.